Yellowstone National Park, it's a land of geysers and hot springs, and honestly a place of breathtaking beauty. But, beneath this beauty lies a sleeping giant, a supervolcano capable of, well, unimaginable power. Scientists have long known about the vast reservoir of magma beneath Yellowstone. That's molten rock, churning and shifting miles below the surface. But the exact nature of this underground giant, it remained a mystery, until now. To understand Yellowstone's fiery heart, scientists needed to look deep underground. They needed a way to see through solid rock, to map the magma chamber and, really understand its secrets. The answer: tiny earthquakes. Not the kind that shake the ground, but controlled tremors carefully created by scientists. These tiny earthquakes would act like flashlights, illuminating the hidden world beneath our feet. To create these mini-quakes, scientists used a remarkable machine, the VibroSeas truck. Imagine a giant truck, weighing as much as 10 elephants. This truck has a massive vibrating plate underneath. When activated, this plate shakes the ground with controlled force. These vibrations, known as seismic waves, travel through the earth. Like ripples in a pond, they spread out from the truck, penetrating deep into the Earth's crust. Deep beneath the breathtaking landscapes of Yellowstone, a hidden world is constantly in motion. The ground beneath our feet is alive with energy, sending out seismic waves that ripple through the Earth's crust. These waves, though invisible to our eyes, carry vital information about the mysteries that lie below. As they journey through the planet, they interact with the complex geology of Yellowstone, revealing secrets that have been locked away for millennia. As seismic waves travel, they encounter a variety of rock layers, each with its own unique composition and density. Some layers are ancient, formed by volcanic eruptions and shifting tectonic plates, while others are relatively young, shaped by the forces of erosion and sedimentation over thousands of years. When these waves meet a boundary between different types of rock, some are reflected back toward the surface, creating echoes that scientists can detect and analyze. Others are bent or refracted, changing direction and speed as they pass through softer or denser materials. This bending and slowing down of waves helps researchers map out the intricate underground landscape. To capture these subtle and fleeting changes, teams of scientists have carefully deployed more than 600 highly sensitive seismometers across Yellowstone National Park. Each device is strategically placed to maximize coverage and accuracy. These instruments act like the Earth's stethoscopes, listening intently to the faintest tremors and vibrations, what some call the whispers of the Earth. Even the tiniest earthquakes, too small for humans to feel, are recorded in exquisite detail. Scientists then examine the data, searching for patterns and clues hidden within the vibrations. Each printout and digital display tells a story about the dynamic forces shaping Yellowstone from below. All of this information is fed into powerful computers, where advanced algorithms process the seismic signals and help scientists interpret what they mean. By piecing together these seismic clues, researchers are able to create detailed three-dimensional images of Yellowstone's hidden underground world, revealing the vast magma chambers, fault lines, and geological wonders that make this place so extraordinary. The results were astounding, revealing a hidden world beneath Yellowstone that few could have imagined. For decades, scientists had speculated about the true nature of the supervolcano lurking below the park's breathtaking scenery. But now, with advanced technology and years of painstaking research, they finally had answers that would change our understanding of this natural wonder forever. For the first time, scientists were able to map the top of Yellowstone's magma chamber with incredible precision. Using seismic imaging and satellite data, they pieced together a detailed picture of the vast, complex system that lies just beneath the surface. This breakthrough allowed them to see not only the size and shape of the magma chamber, but also its composition, and the dynamic processes at work within it. They discovered a distinct boundary, a magma cap, just 2 miles beneath the surface. This cap is not a solid barrier, but rather a zone where molten rock and gases accumulate, creating a volatile environment. The cap acts as a crucial interface between the deep, pressurized magma and the Earth's crust above. This cap, a mixture of partially molten rock and gas bubbles, acts like a lid on a pressure cooker. It traps immense heat and pressure below, while allowing some gases to escape through Yellowstone's famous geysers and hot springs. The balance between trapped pressure and released gas is delicate, and any change could have dramatic consequences. The gas bubbles, primarily water vapor and carbon dioxide, are constantly trying to escape. As they rise through the magma, they expand and force their way upward, sometimes powering spectacular eruptions of steam and water at the surface. These bubbles are a key part of the system's explosive potential. Their presence makes the magma less dense, more buoyant, and potentially more explosive. If enough pressure builds up, the cap could fail, unleashing a catastrophic eruption. For now though, Yellowstone's volcanic system remains in a delicate balance, its secrets slowly revealed by science. Imagine a can of soda sitting quietly on a table. It looks harmless, just a simple drink waiting to be opened. But inside, there's more going on than meets the eye. The liquid is under pressure, with carbon dioxide gas dissolved throughout, just waiting for a chance to escape. Now picture what happens when you pick up that can and give it a vigorous shake. The gas inside forms bubbles and the pressure starts to build rapidly. The more you shake, the more intense the pressure becomes as the gas desperately tries to find a way out. If you open the can right away, all that built-up pressure is released in an instant. The result? A dramatic fizzy explosion of soda spraying everywhere, a sticky, chaotic mess that's hard to control. This simple soda can experiment is actually a perfect analogy for what happens deep beneath the surface of a volcano, like those found in Yellowstone. The same principle of pressure and release is at work, but on a much larger and more dangerous scale. In Yellowstone, molten rock called magma contains dissolved gases, much like the carbon dioxide in your soda. As magma rises closer to the surface, the pressure drops, and those gases start to form bubbles, increasing the pressure inside the volcano. If the pressure from these gas bubbles builds up faster than it can escape through cracks or vents, the volcano becomes like that shaken soda can, primed for a sudden violent eruption that can send ash, rock, and gas high into the sky. That's why scientists closely study the role of gas bubbles in magma. By understanding how these bubbles form and how pressure builds, researchers can better predict when Yellowstone, or any volcano, might be ready to erupt, helping to keep people and communities safe. But there's good news. Yellowstone for now is breathing. The geysers and hot springs that make the park so famous are actually acting as pressure release valves. They allow gases to escape from the magma chamber, preventing a dangerous buildup of pressure. Think of it as the Earth exhaling. These constant releases of gas and steam are a sign that Yellowstone is in balance, at least for now. The discovery of the magma cap and the use of tiny earthquakes to map it represent a major breakthrough in volcanology. This technology allows us to peer into the Earth's hidden depths with unprecedented clarity. It gives us a better understanding of how volcanoes work, how they erupt, and how to predict their behavior. This knowledge is crucial for protecting the millions of people who live near active volcanoes around the world. The Earth is a dynamic, ever-changing planet. Beneath our feet, forces of unimaginable power are constantly at work. Yellowstone, with its fiery heart and breathtaking beauty, reminds us of the awesome power of nature. And thanks to the ingenuity of scientists, we are beginning to unlock the secrets of these hidden wonders.